decimal expansion of real numbers. Based on the results of the decimal expansion of real numbers, we can distinguish rational numbers and irrational numbers. Or we can define rational numbers and irrational numbers in another way based on the results of its decimal expansion. Now first we take the rational numbers. As you know, rational numbers are numbers of the form p by q, p by q, where p and q are integers and q not equal to 0. First we will take the decimal expansion of rational numbers. We just take 3 examples. First, 36 by 100. Here we use log division process. As you know, in log division process, we give importance to its remainders. So, we will do this division of log division method. Here the dividend is less than the divisor, so I put a decimal point here, put some zeros here, whatever it may be. Division, how many times 36 will go 100? 0 times 0, subtract, remainder is 36. Bring this 0 here, there is a decimal point here, put the decimal here. How many times? 3 times, 300, again subtract. Remainder is 60. How many times? 6 times. No. This 0 will bring here 600. How many times? 6. 600. Remainder is 0. How long we will continue this long division process? Until the remainder will become 0. Up to that step we will continue the long division process. When the remainder will become 0, we stop this, then we will get fixed number of digits in the quotient. This is one case. Take another example. 1 by 11, rational number. P by Q form, Q is not equal to 0. Here, the dividend is less than the divisor, so we put zeros here. You have already studied this type of divisions in the earlier classes. How many times? 0, 0, subtract, remainder is 1. Bring this 0 here, decimal point, put the decimal here. Again, 10 is less than 11. Bring this 0 also here, put it 0 here. How many times? 9 times, 99, subtract 1, bring this 0 here. Now, bring this 0 again here, put a 0 here. How many times? 9 times, 99, the remainder is 1. Then again it's gone. It will not terminate. We will not get the remainder as 0. So it is not terminated, it is gone. So we will get a repeating block of strings in the remainder. In this long division process, the remainder is not terminated, but we will get a repeating block of strings in the remainder. As the remainder is repeating, we will get a repeating block in the quotient. I have already told you that in the long division process we doesn't concentrate about quotient. We just concentrate only about this one, remainders. Our main intention is to bring the remainder 0, or we will do the division until the remainder is repeating. Take another example. 1 by 7 here. This is also a rational number. P by Q form. Q is not equal to 0. We just use this long division process. How many times? 0, 0, 1. Put a decimal here. 1, 7, 3, again 0, 4, 28, remainder 2, 0, 2, 14, remainder 6, 0, 8, 56, remainder 4, 0. I bring this 0 here. 5, 35, 5, again this 0 here, 0, 7, 49, remainder is 1. So what are the remainder here? 1, 3, 2, 6, 4, 5, again 1. Then it will repeat 3, 2, 6, 4, 5, 1. So the remainders are 1, 3, 2, 6, 4, 5, 1. Again 3, 2, 6, 4, 5. A repeating block. The number of entries in this repeating block should be less than the value of the divisor. Don't forget that thing. And if you get a repeating block of entries, then actually the quotient will be also repeating. There will also we will get a repeating entries. In the quotient also, the number of entries in that block is less than the value of the divisor. Suppose in a question it may be asked the rational number is 1 by 17. What will be the maximum entries in the repeating block quotient? Maximum will be 16. Now we can define rational number based on the decimal expansion. If the decimal expansion of a number is either terminating or non-terminating recurring, that number is rational number. Or we can say that the decimal expansion of a rational number is either terminating or non-terminating recurring. Then how can we define this only? Rational numbers? Numbers whose decimal expansion is neither terminating nor recurring. That type of numbers are called irrational numbers. Or we can say that for irrational numbers whose decimal expansion is neither terminating nor recurring. Now we can define real numbers based on these terms. We have already studied that real numbers are either rational or irrational. What is rational numbers? Numbers whose decimal expansion is terminating or non-terminating recurring. So what are irrational numbers? Decimal expansion is non-terminating and